if 2x is less than or equal to g of x, which is less than or equal to x to the fourth minus x squared plus 2 for all x, find the limit as x approaches 1 of g of x. So it looks like the squeeze theorem might be applicable here because we have our function squeezed between two other theorems. And this is true for all x, for all real numbers, so it's always squeezed in between. But remember, for the squeeze theorem to give us an answer, both of these outer functions need to have the same limit as x approaches 1. So we've got to evaluate both of those. So let's look at the limit as x approaches 1 of 2x. We'll do that first. We can use direct substitution, and 2 times 1, of course, is 2. That's the easier one. Next, let's look at the limit of x to the fourth minus x squared plus 2 as x approaches 1. That is 1 to the fourth minus 1 squared plus 2, which is 1 minus 1 plus 2, which is just 2. And so because both of those limits are equal to each other, that means that these two functions are squeezing together towards 2 when x approaches 1. And because g of x is in between those, the squeeze theorem tells us that the limit as x approaches 1 of g of x must also equal 2. Now, we don't need the graphs for this. The squeeze theorem gives us that answer alone, but let me show you the graphs just so you can see. All right, so this graph up here is the graph of x to the fourth minus x squared plus 2. And then the graph below is 2x. I know you might think this should look steeper, but if you look at the different scales for the x and y axes, you can see that they're using different scales. I've stretched the graph out just so that we can see things a little bit more clearly. Now remember, we don't know what g of x is, but we know that it is squeezed between these two other functions. So g of x has to be in between these functions. We don't know if it's oscillating or not. We truly know nothing about it other than it's between those functions. This is our g of x. But because these two functions have the same limit as x approaches 1, because they squeeze together, we know that the limit of g of x as x approaches 1 is also going to have to be that same limit, which ends up being 2. This would not work if we looked at any other number that x was approaching. If x was approaching -1, for example, if we were looking here, even though g of x is between those two functions, they don't have the same limit. There's a gap in between that limit, and our function g of x could cross through anywhere in there. The limit might not even exist. It might be doing some really weird stuff there, but because the outer functions have the same limit here, that means there's not any distance between those two graphs like there is here. There's no wiggle room for the middle function, so it also ends up getting squeezed or pinched in so that that limit is the same as the others, which is how we know that the limit is equal to 2.